morning, students. I'm NV Krishna Rao as Assistant Professor in CSE Department, Institute of Aeronautical Engineering College. We are starting with our first unit, Introduction to Compilers and Parsing. So this is the syllabus of the first unit. Here we discuss what is a compiler, what is the need of a compiler, what are the phases of a compiler, and the construction of the first phase of the compiler. So this is an introduction to compilers, definition of a compiler, interpreter and its differences, the phases of a compiler. Then we discuss the construction of the first phase of a compiler, that is lexical analysis. So what is the role of lexical analyzer? Input buffering, recognizing tokens, finite data meta, regular expressions, from regular expressions to finite data meta, pass and phases of a translation. Then bootstrapping and lexical analyzer generator. So this is the different topics that we cover in our first unit. So in the first unit, first we'll discuss what is the need of a compiler. So here we'll discuss definition of a compiler, interpreter and its differences. So here what is the outcome here? Describe the components of a language processing system for the conversion of high level language to machine level language. Here the compiler design is our subject. It's about the compilers in general we use. So the systems will understand only the ones and zeros of machine level language. So we need a conversion of our high level language programs into the machine level language programs. For that purpose, we use these compilers. Here we discuss the construction and designing of the compiler. So all the concepts which are related to the compiler, right? So discuss the phases of a compiler for front end, back end and conversion the source language to target language during the compilation process, right? The first one, what is a compiler? Why need of this compiler? Here the compilers will understand ones and zeros. Writing the programs in machine level language is very difficult. In that machine level language, it consists of ones and zeros, variables, operands, operators and instructions, everything in terms of ones and zeros. So writing the programs in machine level language is very difficult, and finding the errors and recovering the errors also is difficult in the machine level language programs. But compilers can understand only the machine level language programs. Here, writing the programs in simple English is very easy. We can write down the code easy and we can find out the errors in that program also very easy. But the systems cannot understand this high level language programs. So we need of these compilers for converting these high level languages to low level languages, that machine level languages, right? So that we can write the programs very easily, comfortably for our given task. And the compiler task is to convert into the machine level language so that the compilers can understand the task that we have written and they can execute the programs. So compilation is a process that translates a program in one language, means source language, into an equivalent program in another language. That is a object or target language. Here, depending on the machine on which we are executing the programs, it will depends on that object, which object program we have to use, or which target program we have to use. So compiler is simply a program that translates source language program into its equivalent target language programs. So the source language means any high level language program, C, Pascal, C++, Java. So any source language, any high level language programs. Target language programs are machine level programs. Assembly language and machine code in terms of ones and zeros. Right? So microprocessor programs, all are the machine level programs. Right? So we need the compiler for converting these high level language programs to machine level language programs. Right? That is a task of compiler. So programming language, that is problem oriented language, and the target language is machine language or assembly language, machine oriented languages. So depending on the machine on which we are executing, that will be the machine oriented languages. And here there are so many high level language programs, but each program has its importance. C is old, but also till it's needed for operating system programmings. OS programs we use, Unix also we use. Java, we use the new advanced concepts of Java languages for the internet purpose. So now the using of the internet is very common. So we are using this Java high level language program. So depending on the programming language, we use its respective compiler to convert to particular machine language. So on which the programs are executing, right? So compilation is a task of a compiler. What is a compilation? It is the conversion of high level language to low level language. Right? So the compilation is a fundamental concept in the production of a software. Right? Here we are using a OS, right? Or we are using some application. All that applications are machine level programs, but that are written in high level language. So it is the link between the world of application development and the low level world of application execution on machines. Right? A compilation is a process. Right? It is a link between application development and application execution on machines. Right? So a source program will be the input to the compiler. The compiler will do the compilation process, and each line it will be converted. If any errors occur, that error handler in the compiler will generate the error messages. Right? So the compiler main task converting the source program to target program. In that process, in any error occurs, that errors will be generated to the programmer or user. So the error handler will take care of the conversion of error messages to understandable format, understandable sentences. So here machine language ones and zeros. Finding the error is done by the compiler. That ones and zeros cannot be understood by the user or programmer. That error handler will convert the respective ones and zeros into a user or programmer understandable simple English sentences. Right? So the important part of a compiler is error showing to the program. Unless he cannot understand the errors, he cannot rectify the programs. Right? So the compilation process will consist the generating of proper error messages also. Right? So a source program will be the input to the compiler. The compiler will convert this high level language source programs to low level target programs. In this conversion process, if it is found any errors, it will be converted understandable error message. It will taken care by error handler. So executing a program written in a high level program language is basically two parts. The source program must first be compiled, translated into an object program. Then the resultant object program is loaded into the memory to be executed. Right? So executing a program which is in high level language, it is two parts. First part, converting into the low level object program. The second part, using the object program in the memory for the execution. Right? Any program to be executed, it must be in the memory. Right? So while executing the program, the resultant object program is loaded into the memory to be executed. Right? So these are the two parts of the compilation process. Right? Then here another form of a compilation, that is interpreter. Right? Here compilers will convert high level to the low level language program. But this interpreter's task is also to execute the programs, but without converting that high level language programs to low level language programs. Right? So here it takes the source program and input data. It won't translate. Compiler will translate, then executes, taking that object programs into the memory. But the interpreters take the both source program and input data, and it will analysis each line and execute immediately. The compilation will done from the first to last line. Later it is executed. But interpreter takes each line and analyzes the line, programming line, and if need, it takes the input data and executes and gives the output data. So here for each line, the analysis and execution will be done without converting the high level source language to low level object or machine level language programs. It is avoiding the headache of converting that high level source program to low level object programs. So now we'll discuss the comparison between compilers and interpreters. Right? The first one, what is the input? Compiler takes the entire source program at a time and it completely converts to the object program. Right? It takes only one entire program as input. Then it performs the conversion. But interpreter takes a single line of code, a instruction at a time. A single line of code, a single instruction for the execution. It analyzes and it executes. Right? The compiler takes the complete program at a time and it performs the conversion. But interpreter takes a single line of code or instruction at a time for the analysis of the line and execution of the line. Then output. It generates the intermediate object code or machine code. But interpreter does not produce any intermediate object code. That high-level source program will be in the high-level source program only. It doesn't change one form to another form. If you observe, it generates the intermediate code, but it does not produce any intermediate object code. That is a main difference of compiler and interpreter. The first one, the compiler takes the entire program and perform the conversion of the complete program. But interpreter takes each line, analyzes the instruction and execute the instruction. It doesn't know what is the next line of instructions and next code. Simply it will interpret the current instruction. Here the output, it generates the intermediate object code. Right? It converts high level to low level. But interpreters will not convert. That high level source program will be in the high level source program only. It doesn't change one form to another form. It avoids the conversion headache of the one form to another form. So here the working mechanism. It read, analyze the program, it perform the compilation, is done before the execution. Translate to semantically equivalent program in another language. So how the compiler is working? It will perform the reading, analyzing and converting to another source another form of language. So high level language to low level language. Right? But interpreter, it simply takes each line, analyzes the line and executes the single instruction, single line of code. It doesn't convert the complete program to another form. It doesn't know what is the next line also. Each line of code will be read, analyzes and executed. It will be repeated from the first line to last line. The advantage of interpreter is over compiler is the line by line. Compiler takes the complete 100 lines of source program and converts. In any other message occurs, it will give 10 other messages at the end of conversion by stating the line number, some description of the other messages. Sometimes it is easy to find the errors and rectify, but sometimes it will be very difficult, right? So here, if we consider interpreter, it will be done line by line. It read one code of line, analysis. If any other occurs, immediately it will intimate it. So immediately it will be rectified. We can understand it. The other locations is very easily. Sometimes there are no errors in the program, but output will be wrong. So the compiler given with giving a final result, there are no errors. Output is the convert machine level language program is given, but we are getting the wrong outputs. But if we take an interpreters, we are executing line by line. We can understand where the output is wrong. Might be syntactically the statement is correct, but the result is giving wrong. So we can find out the other locations which resulting wrong outputs. That is a main advantage of the interpreter over the compiler. So some programming languages will uses the compilers. Some programming languages will uses interpreters. And a Java programming language uses the compilers and interpreters. It will use both of them for executing the Java programs, right? So later we'll discuss how it is using compiler and interpreter. So here the compiler working mechanism is convert the high level language to low level language. But interpreter, it will read each line of statement, analysis and execute. Here it is advantage for debugging, but disadvantage is if we have a for loop, it is executing for 1000 times. It is executing for 1000 times that for loop. Compiler simply convert the for loop in one time at a time to the machine code, executes 1000 times. It converts in one step and execute the code for 1000 times. But when you consider a interpreter, 1000 times it will read the statement, it will analyze the statement, and it executes the statement. Means it takes more execution time for this for loop. So this is a main disadvantage of interpreter over the compiler. So now what is the working mechanism of the compiler? In a single shot, it convert high level to low level. Then simply it will execute the code for the 1000 times because it is a for loop for repeating the statements for 1000 times. But when you consider interpreter, what is its working mechanism? Read the line, analyze the line and execute the line. 1000 times means it performs these 3 tasks for the 1000 times, 1000 repetitions. So 3000 tasks it is doing for executing a simple for loop for repeating 1,000 times. So the execution time for that for loop by this interpreter will be more than the compilers. So there are so many advantages of compiler over the interpreters, and sometimes interpreters has advantages over the compiler. So depending on the programming language, depending on the task, we have to select compilers or interpreters. So compilers execution will be more faster. Interpreters debugging, finding the errors, executing them will be easier using of the interpreters, right? So that is a difference of the working mechanism between the compilers and interpreters. Then memory. So here high level languages takes less memory. Compiler will convert this high level language program into a different intermediate forms by different phases of a compiler and finally convert to machine code. The size of machine code is very large in compared to the size of source program. Here we have to use the compiler software. The memory required for each phase of a compiler, and we have to maintain, we have to store the all intermediate forms at a time in the memory. So it required more memory because source program, all its intermediate forms and its a final object code form and the softwares for each phase, everything has to maintain at a time. So it requires more memory. Interpreter, it requires less memory. It won't create any intermediate object codes. It won't generate the object machine target programs also. So the high level program will be in the high level only. It won't be converted to other forms. Right? So it's required less memory. Right? So that is a comparison between compilers and interpreters using the memory. Then code optimization. Compiler will read all the statements at a time so that it can know what are the next statements, what are the next operations, so that we can perform the optimizations, minimize the code, combine the task, reduce the task such that execution will be more faster. Because it knows, the compiler knows what is the first task, what is the second task, what is the third task, what is the next task. So it can combine, they can modify. So it can use the compiled previous statements here so that it can perform different type of optimizations such that the resultant object code will be less size and efficient and more faster. Right? So we can apply the code optimizations on the compilers. But interpreter, it will read each line by line. So it doesn't know what is the previous statements, what are the next statements. Simply it will do it's a current statement task only, right? So interpreters see code line by line, and thus optimizations are not as robust as compilers. So we cannot apply optimizations efficiently on the interpreters. So that is another difference of the compiler and interpreter. So speed. Here the compile time, overhead versus execution perform both are considered. Once it is compiled, execution will be done at faster level. But in interpreter, the execution will be slower. Here, the type of the statements the program has also affect the speed of the compiler program execution and interpreter program execution. For example, if a for loop is there, compiler generated object codes executed faster, but interpreters very slower. Here, error detection. In compiler it is difficult, but easier in interpreters. Because compiler will generate all the error messages at the end of the conversion of the high level to low level. So there might be 10 errors, might be 20 errors, might be 50 errors. All are given at a time. Finding the error locations, analyzing the errors and rectifying the errors will be sometimes it will be difficult. Might be a single mistake in typing may result 20 errors or 30 errors or 100 errors. Right? Here in the interpreter, line by line, we will analyze and execute. So if any error occurred in that particular line, immediately we can know and we can rectify and go to the next line executions. Right? So that is a error detection in compilers and interpreters. Here, Proton, COBOL, C, C++, Java, these are the languages which uses the compiler. Here, PHP, Perl, Python, Java, Virtual Machine, these are the different languages uses the interpreter. So depending on the programming language and its features, it will select either compiler or interpreter. Right? Here, hybrid approaches. Java is a language which uses the compiler and interpreter. Here, the advantages of compiler it uses and also the advantages of the interpreters also it uses. The execution will be fast when you compile. But what is the motto of the Java? Write once, execute anyway. So here it uses the interpreter. For the execution, it uses the interpreter. The interpret bytecodes directly or compile some or all bytecodes to native code, particularly for execution hotspots. Just-in-time compiler. Here, compiler, if uses, it will convert the source language to machine language. Means it depends on the machine on which it is executed. So in some statement, it may use the machine instructions also. Means the compiler will depends on the machine. Right? but the compiler's execution will be more faster. The interpreter does not depend on the machine on which it is executing the programs, because the high level language programs will be in the high level language programs only. It will not be converted to low level languages. Directly execute the programs. So here it does not depend on the machine on which it is executing. So here the concept of the robust of the Java comes here. So if you compiled, if you write, simply you write a program once, you can execute on different machines. So that is a main motto of the Java language. That happens with the help of interpreters. But the execution speed of the interpreter is very low. So the Java combines the features of the compiler and the benefits of the interpreter, so that execution will be faster and the machine independent feature of the Java is obtained. Right? So Java programming language uses the both compilers and interpreters. So for today, I'm closing the discussion of the compilers and interpreters, the differences between compilers and interpreters. So in the next class, we'll discuss the compilation process. What are the different steps in the compilation? What are the different phases in the compiler? Right? So today the main discussion is what is the need of a compiler and the compilers and interpreters and its differences that we discussed. Okay, so we continue in the next class.
Like, share and subscribe. Hit the bell icon for more updates.